Morning everybody. We're going to start with a new topic today, a new lesson. We're going to have a look at functions. So let's have a look. The topics to discuss is first of all, why do we use functions? How to call a function. Together with this, I'm going to have a look at parameters to a function and then the different functions available in the libraries, and for this purpose I'm going to concentrate on VB.NET, but functions and libraries really apply to all the common programming languages nowadays. Okay, so first of all, let's have a look at why use functions. Very often in programming we need to break up bigger problems into smaller subsets. So, little piece of a problem and another little piece of a problem and another little piece of a problem, and we solve each one of those big problems section by section. So, in order to code a small section or module, we're going to code functions and procedures. They will have different purposes, so we're going to learn about the rules of when to choose a function and when to choose a procedure after we dealt with procedures. For now, the normal thing of functions would be that a function will use some data, calculate a specific result, one result for me, and return then that result. So a function used when I need to use data, calculate something specific, and return that something specific. Okay, and then functions are, as I said, available in many programming languages. Sometimes they're called a little bit different, not functions per se. Most of the languages will call it functions. In Java, for example, we're going to talk about methods. Okay, but the concept of a function applies to normally all the languages that are used for programming. To call a function, we will need to use its name first of all. Function will have a specific name, and then in brackets we're going to provide the data that would be passed to the function, one value, or if there's more than one, it would be in a comma separated list. The function will then use the data, do its job, calculate something, and return a result. And that result must be saved in a variable. Okay, so I'm literally going to say, hey, Mr. Function, please do this and that for me. Here's the data. I ignore completely the steps that the function takes. I just say, okay, after you've done your job, I get this back, and I'm going to save and use the data that the function returns. A function will normally return only one value for me. When I passed data, or it's called parameters, to a function, I need to take care of two things mainly. First of all, the sequence of the parameters, and then linked to this, the number of parameters passed. If a function says I need 3 pieces of data, I can't just provide 2. If a function says first give me this and then give me that, that's the sequence in which I need to give the data to the function. So we're going to touch and discuss on that. If I now have a look at the different functions available, I first of all want to start with some of the functions in the mathematics class. So there's a class already coded in the .NET environment that will supply quite a few functions, common things that we need to do in mathematics. It's coded already, it does its job. I need to supply the data, and I get the result back. Let's look at the first one, the easiest one. It's a function called math. It's coded in the max. It's coded in the mathematics class. So whenever I'm going to call it, I need to provide the full name, math.max. This really specifies the max function is saved in the math class. This function, we're going to learn about that in a moment, takes two parameters. So instead of specifying dim to specify I want a variable, whenever I get data, whenever we code the function itself, and we're going to only look at that a little bit later, we specify this function receives data using the reserved word by val. Okay, so it says it gets a number called number 1, it's a double, and then it gets a second parameter called number 2, and it's a double as well. And this function returns a double. The data type that the function returns is really important. So here at the end it specifies this function sends back a double. The function is overloaded, so it can be used with any of the data types. So I can call it with integer or decimal or any of the other data types. An example will be something like this. So I'm going to set 88 and 13, these would be integers, and the largest of the two would be returned and saved in largest. And if I use 88 and 13 as the parameters, then 88 will be saved in largest. Okay, so here we've got name of the function, it's math.max, the data that it needs to get, 88 and 13, literal values used for this first example. I get the largest back and I save it. If I go have a look at a example, then for now the user can only enter one number. We get to display the result. I've got a calculate number button. So if I want to go and calculate the largest value, I'm just going to save the data in result always. I specify math.max, and now it tells me the first number, and in this case I'm going to use number for the first parameter and 100 for the next. I'm not going to ask the user for two numbers. I get only one number from the user and I compare that to 100. So if I am to run this program, and let's say I type 78, the moment that I click on calculate, my program compares 78 and 100. It sends that to the max function, and the max function sends back the largest of the two, which would be 100. I didn't provide a clear button, so I can't delete this result. But if I now go and enter 140 and click on calculate, then again the program compares 140 and 100 using the max method, and it sends back the biggest of the two, which would be 140, and this 140 is displayed. Okay, so using the method, I only really need to specify what? Name of the method, the data that it gets, and I save the result. I don't need to worry about the steps that the method takes, the precise process that it takes. That's not my job. My job is just to say, Mr. Max method, please give me the biggest of those two things, and it's saved. Okay, so the process of using functions takes a lot of the shall I say worrying about what would happen away from me while I'm using it. I just simply need to specify name of the function. This is the data, and I know the function is going to do the right job, always. Okay, if we then have a look at the list of functions available, then there's quite a few. And I only again highlight the most important ones. So there's an absolute method. Absolute value is the positive of any number. So if I call it with a negative number, the positive of that number is returned. If I call it with a positive number already, the positive still of the number would be returned. Math.ceiling is function that's sometimes used. It returns the smallest whole number, greater or equal to the specified number. So it really takes this number and instead of rounding it using the normal rounding rules, it gives me, if this is rounded and it's got any decimal positions, it gives me the next higher number. So 88.0001 will also give me 89. Sometimes we might need to use this in some of the calculations if we need to. Let's say I, for example, go and calculate. I need to go and buy boxes of sweets to give the sweets to the children. And I'll go calculate, I need 3.12 box. So in order to give to all the children a box of sweets, I need 4 boxes, I can't go and buy 3.12. To round it down to 3 would also be wrong. I still need to buy 4 boxes in order to give at least whatever to everybody. So math.ceiling would be used in such a situation. I get math.floor, and here we sort of do the opposite as ceiling. We go to the next lower number. So it doesn't matter what's the decimal positions, we don't follow the normal rounding rules. We go down one more number. So sometimes in a problem you might get a situation where you need to go down to a lower number, and then you use floor. Math.max I discussed to get the largest of two numbers. I've got math.minimum to get the smallest of two numbers. Math.power I discussed previously. So this would be some number raised to the power of the second number. So very important, the second number is the power, the first number is the base. So if I want 10 to the power of 5, I'm going to specify 10 to the power of 5 like this. And just leave it as it was. Math.round, and here we round using the normal round rules that you know. So I though have the option to specify how many decimal positions I'd like to use with a second parameter, the number of decimal positions. So over here, if I don't want just 1 or 2, I can specify 4 decimal positions, and the number is rounded according to the normal rules that we know. So 7 over there specifies that we need 0.23. The 2 is increased. The normal rounding rules are followed. Math.square would be used. to get the square root of some or another number for me. And now the important part. You don't need to be a parrot when you know any of these functions. Whoever coded them did a proper job, and there's proper documentation for them. I can follow one of two methods to use the math class. So if I want to use the power function, the moment that I type math dot and wait a moment, the whole list of functions available pops up. So if I want to use the power function, press tab, begin bracket, or again, whenever I call a function, I always need to provide begin bracket, open bracket. Any function or procedure that we code would at least need begin and open brackets. And now have a look. This pop-up documentation tells me X, the first thing that I specify, the first piece of data, would be a floating point number raised to be raised to a power. So if I want 10 to the power of 3, this needs to be 10. And now the next parameter is highlighted. Y. It again can be a double precision floating point number that specifies the power. So if I want to raise 10 to the power of 3, this is how I'm going to do it. And the documentation helps me with this. If I wanted the number that we typed in raised to the power of 2, I would simply specify number raised to the power of 2 like that. So if I were to run this program, and we've got 4 raised to the power of 2 gives me 16. If I go 10 to the power of 2, gives me 100. If I get 15 multiplied by 15, 15 to the power of 2, 225. Like that. Okay, so this is one way of seeing the data. But there's a full list of the VB.NET documentation available on the internet. So if I copy this link and I open up, then I've got the math function in Visual Basic and all of the data regarding it. So over here is the list of methods, and you'll see there's quite a few more. I didn't discuss all of them. I can have the sinus rhythm, the cosinus, a logarithm, the square root that we discussed, but there's quite a few different methods not discussed. So if I were to click on any of these methods, it takes me to the documentation of that method, and here I can see two parameters. It's the number to be raised, and the second one specifies the power, and this method returns a double. Learning to read the documentation is extremely important, and we're going to go and work with that as we go along. I just want to show you something else. See quickly if I get to it. Here we go, the fields. There are a few constant fields available in the math class as well, and this is of particular importance, pi. So whenever we need to use the pi signal in some or another formula, I know I can type 3.14, but that's by no means a accurate value. If I use the constant field from the math class, then I've got a accurate value, and I'm going to use it like this. If I need to calculate number multiplied by pi, it's class name dot, and I've got a p, I can specify pi. So math.pi, that's the constant value to specify the pi number for me. And then just a bit further explanation. Once we know the math class and all the different functions available, and we move to any other language, and for this example I'm going to use Java. Okay, have a look at the documentation. Guess what? Documentation available for Java. There's a math class, constant pi, there's some absolute methods, there's a ceiling method, there's a floor method, there's a few more, there's a max method and a minimum method, and I scroll a little bit down. Then there's a power method and a square root method. So can you see, if you know what you're doing in one language, really easy later on to go over to a next language. Next up, I'm going to discuss the different methods or functions then that's available, that we're mainly going to use to convert string input from the user. And there's actually 1, 2, 3 different ways that we can achieve the same result. So first of all, I can use the functions that came from an earlier Java VB version. Convert to double, convert to decimal, convert to integer, the most important ones. I can also use some of the classes and methods that were provided using the .NET framework. There's a class called convert, and it's got methods, and I'm just going to scroll down a little bit. Here's the first one that we might be interested in. To decimal. There's also to double, to integer, as well as other methods that we need to. So using this convert class, I can convert a string to a decimal or an integer or a double. Exactly the same as what? I can convert a string to a decimal or an integer or a double, either using one of those. And then we've got the third method that's also available, the Visual Basic Data Type in the .NET environment. If I just go to the double data type, I've got a double. And if I have a look at the different methods, then again I've got a method called parse. This will convert a string to a double precision floating point number. So more than one way to do a job, and that's why you might find that some people, over here it's the try parse method, not the parse method from the double or then integer class. Some people prefer one method of conversion and others might prefer another. All three of these lines, line 12, 13 and 14, converts the data typed into the text box to an integer. So either using the cint function, the convert to int 32, or integer.try_parse, or then the integer.parse method would also do this job for me. You can literally pick whatever you feel most comfortable with. I would normally suggest to students, if I can comment those two out, the following. As programmers, we're very lazy. So if we go with the suggestion from Visual Basic, then that's perfectly fine. Acceptable. And in programming, more than one way to do the same job, any one of them would be perfectly fine and suitable for us. Just as an example, again, we can go and have a look and see, but hey, this is also provided for us in other languages. So if I go and close those tabs, if I go to Java 8 documentation, and I'm just going to quickly have a look at it. I've fixed the error in the link, and I've updated the PowerPoint slide. The class double of the Java documentation provides quite a few methods, and one of them would be called parse double, and this takes a string and it converts it to a double data type. So again, knowing how to do a thing in one language assists you in converting or learning a new language later on. When I go to calculations, we sometimes need to convert as well. And let's just learn about these conversions needed when I do calculations. You already know that there are different types available. And these different types will store data using different bytes. So an integer would use 4 bytes, a double 8, and a decimal 16 bytes, just as an example. Because of these different data sizes, different sizes of blocks in memory, so whenever I specify I want to use a double, 8 bytes in memory would be used. And this now determine how, shall I say, I can assign data. So if I just, for a moment, ignore that, and then let's go and specify, I've got price as well, so price will be a decimal. If I start off and I assign 10 to number, then I've got no problem at all. 10 is an integer, number is an integer, can be assigned. If I go and specify I want to store whatever is saved in number in result, so take whatever is a number and save it in result, then I've got no problem as well, because this is an integer, 4 bytes, that's a double, 8 bytes, and I can easily, this 10 is converted to, let's say, something that looks like that, 10.0. So this is called an automatic conversion. So perfectly fine. if I go and specify that whatever I've got in price, let's just use literal values for now. I want to save the data that I've got in price, and I want to save 10 as well. Then again, no problem at all. Data can be converted. An integer is 4 bytes and a decimal carries 16 bytes. There's plenty of storage space for the integer. But it doesn't always work like that. If I want to go and specify that I want to save something like that, 10.5 in number, then I've got a syntax error. I've got a problem. It would tell me option string doesn't allow me. Why? Because 10.5 is not an integer and it can't go in there directly like that. If I change the number to an integer, there's no problem at all. But we can't just sometimes change the number as is. I can round the value. We've learned about the math.round method. If I change the code like that and I go with the suggestion, then have a look. So this program is not going to get any input. This part over there we've discussed already. If I take number 10.5, convert it to an integer, save it in number, and then just go and display the data, I've got 10 as it is. So take note, I can convert the data, but now me, the programmer, I said how I want to convert the data. If I opt for straight, this is truncation. It means delete all the there we go, delete what doesn't fit. So the 0.5 is not rounded, it's thrown away, truncated, deleted. So I have the option to go and say, okay, I want to round this value. There's a round method. And if I take 10.5 like that, then I've got an error. Why? Math.round. If I just go have a look at the documentation again, there's more than one method. Let's go up and down in the list. If I give it a double, it gives me back a double. So if I've got 10.5 like that, it rounds it to the next integer, but it gives me that as a double result. I will still need to take whatever data is given to me and convert it to an integer. So now if I run this program, okay, here the program is running. Take note, I don't need to give any input. Currently I'm literally taking a data, rounding it, storing it result, and then displaying it to the user. If I click on calculate, then I might have expected 11, but I get 10.5 here. The reason would be lying hidden here in the round method, in the documentation of it. So if I go to the math class round method and I go read through it in detail, I might come to this part where it explains to us how this method rounds. So a 4.5 would be rounded to 4. It's actually rounded down. That's why I've got 10 in my output. The method did exactly what it was supposed to do. And I would be able to read a little bit further if I need to learn a little bit more about how the math method does its job. So if I close the program and go specify 10.6 and run it again, just move my screen again, click on calculate. Now I've got 11. Okay, if we continue with the type assignment, if I take price and I assign 10.5 to it, then I've got an error. 10.5 is seen as a double. I can't just assign it to a decimal. So there's two ways around that. Either can add a D at the end. It specifies convert the 10.5 to a decimal, and now it can be stored. Or if I go with the pop-up help, it says I can do a conversion like that. I think experienced programmers would most probably just add a D after a number because they know the rules and they work very well with that. But if you use the convert to decimal function, it's still fine. So now we get to the point that I want to make. Sometimes when we do calculations, price is equal to result times number. So this is just a formula. It doesn't mean really anything. I want to show you the type conversion problem that we've got. Then over here on this side, I've got a double multiplied with an integer that would give me a double result. But I'm trying to save that in a decimal. So again, I've got different types, and thus the language environment is moaning at me. I can go and say, okay, convert that to a decimal so that the data is saved for me in the right variable. If we can go back to the presentation. So I've got the rule of thumb thing that you can always sort of take. Automatic conversion, so where I, the programmer, don't need to specify anything. So when I go either with equal types, assume result is an integer as well. When I go from a smaller data type to a bigger data type. Whenever I go with data that's assigned between different data types, if I go with a bigger data type, this is a double, and I want to assign that to number, then I will need to add a conversion. I will need to specify how the data is converted. So I can specify the way in which the data must be converted. Do I want to use convert to int? Do I want to use one of the math.round methods with their rules? Or what do I want to use? Okay, so whenever I go from a bigger data type to a smaller one, remember the different sizes now are important. Then we need to take care of these conversions. And under normal circumstances, convert to int, convert to decimal, convert to double. It's perfectly fine. Whenever I want to display output, I need to do conversions again. And normally best would be to use the toString method to display numeric data. With the toString method, we can specify how the output must be formatted. So if I've got something like that, it tells me, or tells the computer, take the price, convert it to a string, add currency formatting to 2 decimal positions, and now the value will automatically be rounded to 2 decimal positions when it is converted like this. I can specify I want just 3 decimal positions for the number. N3 converted to a number with 3 decimal positions. Or if I don't want any conversions, and this I can really only do when I've got an integer. I don't need to specify any conversion. An integer by itself is just converted as it is. When I've got a double or a decimal, I will need to specify conversions. And again in Java we're going to do something similar, but it's not discussed at this stage. So as a summary, I've discussed why we need to use functions. It's really to break up big problems into smaller problems. We saw how to call a function. We need to specify the name of the function. We need to send the data to the function and we get something back. And then we had a look at the different functions available in the mathematics class, and the different functions to convert between a string and the numeric data types, mainly for input. Whenever we need conversions between the numeric data types, we will use it when we do calculations. And when we go convert the numeric data type back to a string to display it, we need conversions as well. This text property would be a string, so the data must be converted to a string for me to view it. Please don't use, in this situation, convert to string, because then very often if I've got a double or a decimal, we're not going to do the rounding and display the data as we need to. Always go and display data using the toString function. That returns the string equivalent of the number. So, thank you very much.